Okay guys, today we're going to talk about the dot model in physics. And this is a really excellent model, especially for those students who are kind of struggling a little bit with the math, because the dot model of looking at motion doesn't really involve very much math. It just involves your ability to visualize how things are working. So let me just explain this model. I'm going to draw it on the board for you, but let me give you a kind of a hypothetical situation that I think will help you to understand the value of the dot model. So let's assume that we live in a magical world where my heart will leave a dot in space at wherever it was. It will leave a little marker, kind of like leaving a trail of breadcrumbs, every 1 second. So right now, I'm standing in the same place, so my heart would be leaving that dot in the same place over and over and over and over and over again. So that dot would start to become very, very dark. That would indicate that I was there for a long time. But as I start to move to the side, or move backwards, or over this way, I would start to see imprints of my heart. That little dot is going to show me moving through space. And it's going to show all kinds of really amazing things. So for example, it would show where did I travel at a constant speed. And the way that would be revealed in the dot model would be that the dots would be evenly spaced. So in places where I look at this trail of dots that I've left, when I leave the building today, I'll walk through the door here, I'll go down the stairs, I'll see a little trail of dots going down the stairs, around through, all the way to the first floor, out through the door right there. I'll see those dots move across the courtyard over to my car. Then you'll see the dot will suddenly get lower because I'll sit down in my car and now my heart is at a lower position. And so it's leaving the dots a little bit lower. I'll drive out of the parking lot. I'll see the trail of dots on Pulaski Avenue as I pull away. It will leave a record of everything that I've done in terms of my motion with no math involved, but showing me where I traveled at a constant speed. It will show me if I slow down. When I slow down, it'll start to look like this. The dots will begin to get closer together, showing that I was not moving as quickly. In each second, I did not cover as much ground. I can also see when I sped up. So for example, when I stand in place, I get a big dot because it keeps putting the dot in the same place over and over and over again. But then when I start to move, I'm going to see the dots start to get spaced out more widely. So this dot model is an excellent way for you to describe the way something is moved, and you could describe the way the dot model would look, or you could look at a dot model to identify all kinds of things about motion. Places where we traveled at the same speed, we slowed down, we sped up, but also other things. I could see when I turned. I could see if I started going upward. As I said, I could see when I sit in my car, I'll see the dot model, my whole heart will move down a little bit, and so now I'm in a different position. And so this dot model is a very simple way of thinking about motion, but really powerful. I mean, it really allows you to see basically anything that you could see in motion will appear in the dot model, but you don't have to do any math to be able to use it. So we're going to use the dot model. We actually have a machine at school called the ticker timer. And this ticker timer, I'm going to show you in the when we start looking at the lab. It has a long piece of paper. I could connect it to me, for example. I could tape this piece of paper to my shoulder, and I could run it through the ticker timer machine. And as I move, the little piece of paper will get pulled. And what will happen is it will leave a trail of dots on the piece of paper, which is creating the dot model of my motion. Now, we don't really care about my motion. We want to focus on the motion of some of the vehicles that we looked at from the average velocity activity. So we looked at Tommy cars, and we looked at battery-powered cars, we looked at the pullback cars, and we looked at the flywheel cars. One of those cars demonstrates constant speed or constant velocity really well. So you think about which car would we use if we wanted to see a dot model which showed constant speed or constant velocity, which vehicle would we choose? And then we'll apply that machine to it so that we'll create the dot model, and then we'll be able to look and see where the car sped up and slowed down, where the car traveled with constant velocity. And while you don't have to do math with the dot model, you can do math with the dot model. You can make measurements of the dots to figure out how far they've moved. And if you know the time difference between the dots, then you can use that to figure out the speed. How fast was I going here? How fast was I going here? What about back here? I can use the dot model to add math to it, the mathematical model, and then the model becomes much more complete and becomes much more able to represent the motion of the object. So that's where we're going to go with the dot model. It's occasionally sometimes called the particle model. So hopefully you guys will be able to use that model to great success in the future.